Hello all, this is Christos Christiadis from Aqua Agitators, and today I have the pleasure of hosting Sandro Hansen. Sandro, good morning from Amsterdam. How are you?
Fine, good morning to all.
So, long life veteran in the water industry, having a lot of operation experience, and now promoting AI solutions for the sector. Would you like explaining us a little bit of your background and what you're doing now with Turing?
Yes, thank you for having me. Well, first of that, as you said, I had a lot of, call that, working on operation from water and wastewater systems. And I went all the chain from engineer to supervisor to manager and then director for some big companies and doing stuff in almost 3 or 4 continents. But then in all these projects, a lot of different technologies, but at the end, always we had to handle with problems, with some errors, with some issues in these systems. And I always asked myself from my engineering background that it should be an easier way to do it. Okay. And then when the pandemic arrived, of course, it was very bad for everybody. But on the other side, we had a lot of home work, working from home.
Mhm.
And I had some time and I started to study more about AI and IT and things like that, making online courses. And finally, I decided to change my career. So now I work with AI, focused on the water industry. And what we do in Turing is create tools that would help operators with smart insights and also some kind of automate operation where it's possible to have this better operational handling from all these challenges that all these companies have. The idea is not to be totally automated, but sometimes automated, sometimes with human intervention. And the scenario is, of course, you start always with data, you see.
What do you think has changed in the last years in the water industry that makes, how can I say, the application of big data and predictive models more necessary than ever?
I think the first change is it's that now it's possible. You see, because before we have many manual operations, so you got there out in the field to open valves, you took a portable instrument to make measurements there in place. That's how we did it for many, many years.
Hmm.
Okay. And in fact, it worked. Sometimes better than others, but it worked well and we got used with that. But then we started to have online sensoring. The automation went into this plant. And at the end, what I think that was maybe the something that we lost in the industry is that the smarter operator, the most experienced operator now, it turned to be a SCADA operator. He just stayed there, seated in front of the computer, handling problems through SCADA system because now everything is automated. And you have less experienced people in the field managing what needs to be managed. So now we have data, but we are not using the human power in the best way.
Hmm.
So in my view, for example, all these routine stuff that needs to be done and managed, now we have the technology also because we have the computational power to do it through not only automation or rule-based uh, automation, but also with AI. So you have really insights from the data. You have a perception, for example, if something is getting slowly worse, not quite into the alarm limit, but just showing you that in the future, a problem will happen. And then that's something that a human do very well. But if you have an alarm-based SCADA system, it will not identify for you until maybe it's too late.
Hmm.
Okay. Also, for example, in this old automation concept, for example, you have a lot of alarms for everything. So the operators get just overloaded. Sometimes you have 10, 12 alarms happening in the same moment. It's hard to identify what is important and what is not. Sometimes you have an alarm for one equipment that is under maintenance, so it's not important at that moment. But if the equipment comes back, it may be a problem. So also these, and the plants are getting bigger. You are getting more and more information. All this data is recorded, and we are not using these in the best way.
Yeah.
Okay, so that's where more advanced operational systems can really help. And we are in a moment that also operators can understand this. You see, because we need human interaction. It's not a magical solution. It will be a lot of work to do it together.
Just to clarify, you're preaching to the choir, right? I'm all for more, let's say, AI inclusion in the day-to-day operations, if you can say it's AI. But as also you said, now we have the necessary tools, right, to measure digitally on a continuous basis and have the operators have a better overview of everything. I think it's pretty critical, especially as for the bigger operations. But do you think it makes sense for smaller to medium projects?
Yes. For example, if you have some small project, these companies that have these small projects, usually they have a control center to manage this. Because, of course, you don't have people on the field to operate everything all the time. If you have industrial operations, for example, it's really hard to have someone there handling stuff during the night shift or during weekends.
Mm-hmm.
And of course, especially wastewater systems or biological systems need some kind of attention.
Mm-hmm.
So in smaller operations, what I see like a drive for this kind of solution is not only the savings, because of course they are smaller. So if you have a 5% energy saving, it will not be a huge amount of money,
Mm-hmm.
but you have a lot of efficiency and you can manage a lot of operations
Mm-hmm.
with a smaller crew, and then you can give attention where it's really needed.
Yeah.
Okay, so I see this like not a better solution, but is almost to survive, because these operations, they are usually cost driven. You see, so you need to be with the right performance, but also cost is really critical in these operations because they are smaller.
And what about the bigger ones? What are the benefits that you have seen in applying the AI systems?
So in bigger systems, the main benefit that I can see, a global operation efficiency. Because usually, for example, when you try to optimize something, and everyone that worked in real operations know how it works. So you start in the morning and you say, today I will optimize this.
Mm-hmm.
And then you grab a coffee and we start, and then someone enter in your room and say, well, we need some chemical that has not arrived, or an important pump has broken, or someone has a problem. And
Mm-hmm.
then you go to the real life, solving these problems that were not planned. And at the end of the day, you have not made any optimization because it was not possible. And then you say, tomorrow I will do it. And tomorrow never comes, because then there is another problem. So running these routines of optimization in the background, keep a focus on efficiency. That, of course, all the operators want to do it, but they just can't handle it, don't have time to do it. And so we are saying here about saving energy, saving chemicals, avoiding water loss, for example,
Mm-hmm.
and also guarantee the quality compliance for all the products in 100% of the time.
If someone puts a knife on your throat and asks you to put down some rough numbers for OpEx optimization in, let's say, a big desalination plant, what would you provide them with?
So in general terms, and it depends a lot of the sensory, and of course the control equipment that you have on the ground. For
Mm-hmm.
example, for sure you need VFDs in the pumps and things like that,
Mm-hmm.
and some kind of flexibility. But we can say that you can get 10% energy savings, maybe 20% in chemical savings.
Mm-hmm.
Um, Altogether, these with some kind of other OPEX optimizations and maintenance optimization, it can be at the end 20% in OPEX that maybe you can save.
Okay. That's
Okay.
significant amount, right?
Yes, but I'm starting from a plant that everything needs to be perfect to be optimized. You
Mm-hmm.
see, you have to be sensor. Usually, the real life is not like that. You have always issues or
Mm-hmm.
limits. For example, sometimes you can't go perfect recovery in a desalination plant because you have other issues. So, but it's a good goal. You see.
So, are there any risks to applying these digital tools in the operations day to day?
Yes, it's a very common question because when we talk about AI, people's always come in their minds 2001 and Space Odyssey or the Terminator movie, you see.
Mm-hmm.
And but what I see that you need to know the risks to manage them. So, for example, what we do in our company is a very, of course, cybersecurity important risk mapping because you need to avoid hackers from accessing the system. And every plant, every country, they have a lot of guidelines related to data, to issues. Even we can do on-premise assessments. So the plant is not connected, the model the AI model is not really connected with the internet. So it's a more safe approach, for example, that can be done. But the risks so are cybersecurity, as I mentioned,
Mm-hmm.
and also you need to have a very good evaluation about the model. We usually say that it's like a child that is in training.
Mm-hmm.
So in the beginning, you have to have really control from what it's doing and you have to give hard limits for any model, and you need to understand how it's performing. And under time, when you have a model that is well trained, you can give it little more liberty. But again, always monitoring, for example, what we do, we always monitor the errors that the models are generating
Mm-hmm.
because sometimes the data is changing, the situation on the ground is changing. And if you have an old model, you can check, for example, you predicted something, then you will see what happened. And if it's not quite close, something is happening here, and you need to stop or you need to retrain the model
Mm-hmm.
before doing other predictions. So that's kind of online monitoring to help understand and is not only the result, but how the model is performing. You see?
Quick question may sound stupid coming from someone that doesn't really know the specifics. So we are talking about creating essentially predictive models with big data, right? And you said yourself that essentially you need to train the model to optimize your operations. So how much time does it take from the moment that you start to the moment that we actually get the optimization that we're after?
In fact, what the models just can handle situations that they have already seen. You
Hmm.
see? So, for example, I would say to you that we need 3 to 6 months data. But
Okay.
of course, if we are talking about a desalination plant that has a lot of differences between summer and winter, you
Hmm.
need a 1 year data.
Hmm.
Because if not, if you have only winter data, you will not be, even it can handle it, but it's not perfect to handle some region or set point map, for example, that you never saw before.
Hmm.
So, and that's also important because you also need to monitor this. You need to have, for example, information about where the model was trained, and
Mm-hmm.
what is the situation that you are seeing at that moment.
Mm-hmm.
Because if it is, again, too much different, or if you have never been there before, usually you need that's another risk, because that you need to monitor to avoid bad decisions.
Mm-hmm.
Okay. So, for example, what sometimes we do in this situation is send an SMS to the operator or to us, because that's something that we do. I think we are not only a software company, we are uh, water people, experienced water people that produce a software for water companies. So we know a little of the process,
Mm-hmm.
and we can help the model, for example, but also, for example, call for, you are in a totally automate position in the operation. But then if you be in a situation that you have never been trained, it will call the operator for some kind of assistance. For example, I want to do this.
Yeah.
Do you agree? Makes sense. Things like that.
Yeah, and I think it also, so you have a lot of differences, case by case, I guess, with with the local environmental conditions, with the way that the system was designed. Yeah, so pre-treatment from pre-treatment varies widely, I'd say. And how does the program really um, adjust to all these differences?
So usually you have one state evaluation, and then you have an action.
Hmm.
Okay. So usually you need to have state understanding where the plant is.
Hmm.
And based on that, because it has seen a lot of data and was training using, usually we use neural networks for this kind of training, because, and it will see the best way, the best decision to take from that point. Sometimes we also use some kind of helpers to that. For example, what is the tendency? What's happening before? So, for example, if the water inflow, the water quality that is entering your system is getting worse, you can, for example, take a more conservative decision. Okay, because it may be uh, a problem in the future or not.
Hmm.
So then the system can learn, for example, like a flag. Here is something that is not yet a problem, but may mean that, for example, the pretreatment has a problem, or you have for example, a algae bloom there that is coming. And even you can get, for example, external information. You can use satellite photos for algae blooming identification. You can use weather information, for example, for sewer management. You can use other kind of external data for
Yeah.
this. And so you can add variables behind this decision to try to cover everything. But of course, you need some time to do it.
Yeah.
And usually, what people want, or they hope, for example, is a solution that would be magic and will handle everything.
Yeah.
And that they don't need to invest time to correct it. You see, but on the T0 in the beginning, you always need to have someone inside the plant helping the provider to make this solution be perfect and cover, well, the perfection never exists, but covering most of the cases with safety. And that's part, that's me as an application specialist is what we do more. You see, we look at the data and we try to work with the operators to understand what's happening in the plant and how to improve the models to do it in the best way.
Yeah. Experienced operators and engineers for troubleshooting won't go away. I don't think ever. Yeah, maybe it's all about making their lives easier. Yeah, that's what you're trying to do, I guess. Um, so if a company wants to come to you and use your digital products, what are the first steps that they should do to apply them?
Okay, I always one of the alternatives, or I will use here an example from 4 steps. So the
Hmm.
first step would be the commitment from the top management,
Hmm.
because you can't have a perfect or a very good digital solution if you don't have your people together working on it. You
Hmm.
see, because every plant is maybe slightly different. You have very special situations. So for the product to be really useful for the operator, they have to invest some time. And in one moment during the project, in any project of any digitalization project, we will be back to that question. We really want this. Are we sure that we need to go on? So if you have this top management uh, agreement from the beginning, it's easier to do that. After this, we have a second step that is a physical assessment, and not really physical. You can look at the PNIDs and all the papers you see, but you need to evaluate if there is data, if there is sensors that would be able to really do the machine learning. Because sometimes what you need to do is another previous step to help the company to invest in sensoring and some kind of automation on having VFD in all the high pressure pumps, for example, using this desalination example.
Hmm.
So sometimes if you don't have all this infrastructure, of course, a very good data server or a cloud server to manage all the data. Because if you don't have this basic, even the best program will not work. We
Hmm.
are talking about garbage in, garbage out. So you need to be sure that you can take actions, that the data is correct, that you have data to do it. And as we have a lot of experience doing this before, we can make this evaluation. And usually that generates a report that so the operator can take the decision to go on or not. Okay. Then we have a third phase that is define the real objective, what questions we will do to the model, what are the pain points for the client in that operation.
Hmm.
And then we will work with the historical data to do this model creation, model training, and testing.
Hmm.
Because then you need to, I would say that is a third phase, but it's two phases inside it, because first you go to the historical data and then you go to the real world. And it comes back to historical data and go back to real world as much times as is necessary to have a good model.
Hmm.
And when then the operator has some kind of confidence and this trust is not generated in the first time, you go to a fourth phase that is the real application. And even in the real application, you still will have some human intervention, less than in the third phase. But as I told you, sometimes you will get into states or situations that you have not seen before. And you need some feedback from the operator. What is the best? The model, for example, can say for 50% chance I see this to do, 20% this, 15% this, 15% this. What is the right option? And then the operator gives this feedback that, again, this information is, this knowledge is collected by the system. And then after that, if you get back in that same state, the model will know what to do at that position. So you And also you will generate a lot of reports. Our system work on that and plots. And then the operators need to see them and have insights by themselves because the idea is that the system will never cover everything.
And this won't happen on a case by case scenario. But do you think that we, as a wider industry, should share big data in order to improve our systems?
Yes, what I see that maybe is one problem now is digitalization is that we have many tools. The tools are all there, but
Yeah.
then you have an SCADA system, then you have a different area where you have a data storage system with all the sensors and the information that you get from the plant. Then you have a different system that manages the predictive maintenance from the plant. Then you have another system where you do the performance report.
Hmm.
Then you have another system where you handle, for example, the chemical supply. Uh, and maybe when we talk about desalination plants, for example, you also have another system from the chemical provider that calculates the doses and make the normalization.
Hmm.
And if you are going to a city system, a municipality system, you also have the georeferential systems, the GIS. You have all the field systems that they have. And all these just not talk with each other in a perfect way. It's really easy to get lost in this situation. So what I think that we should do, everybody is working in the digitalization, but
Hmm.
we should do better as a suggestion is to have all this integrated in an easy way. So you can get all this data together and you can manage all this information. And of course, it will be a lot of information.
Hmm.
So how we addressed this in our company, for example, we now also supply SCADA system because it's where everything starts. It's there that the data is generated. And then you can take the data directly to a good database server. And then later, maybe you can do an optimization on this SCADA system or some AI routines. But also you can include there, for example, the uh, predictive maintenance. So you can, again, automate, for example, uh, if you have an area that is in maintenance, you just can cancel the alarms in that area, the operational alarms. So
Hmm.
you avoid an over uh, extra too much information, overload data. So all this can be done, but you need to have all this in the same environment. And that's, and of course, every plant has a different software. And so it's really, we don't have like a standard for that at the moment.
I don't think standardization is feasible, if you ask me. Yeah, because you have 100 different. The water industry in general is a very fragmented industry with lots of solutions, lots of solution providers, yeah, that give a different combination in every project. The way that I think maybe to go forward is, as you said, to learn how to make these systems talk to each other. Yeah, because I don't think you'll ever get away from different combinations. My last question would be a two-part inquiry. One is, what do you think the future holds for digitalization in the water industry? What other developments do you see incoming? And two, coming back to what you said earlier about cybersecurity, do you think that solution providers such as yourself should include cybersecurity in their provided packages?
So first about the desalination industry. What we see now is that we are having bigger plants. you see, that are
Hmm.
starting already in a very low tariff and focused on this kind of solution is just feasible if you have a really good operational system. Because if not, on my understanding, it would be really hard to get this to be profitable in this market without being totally efficient. You see, so they need every plant that is coming in the market now. They should have a optimization tool because I see as the only way to be profitable. You see, because it's really hard to operate a plant. I have been in real time operations for many years, and you can get a list of so many things that can happen. You just can't predict everything. And it's really hard to do on a day by day basis what was defined and expected in the design phase.
Hmm.
Um, about cybersecurity, what I see is that sometimes we see a trend here that some plants are going from cloud systems to on-premise systems.
Hmm.
So this is the best cybersecurity position, okay? And if you go to a cloud system, the provider should be together because you need to have kind of very good planned barriers
Hmm.
from the beginning. It's the kind of situation that you just can't have band-aids. You see, the solution from the beginning needs to be planned to be safe.
Hmm.
And you can do that without planning together with the provider. I'm not saying that we will provide the equipment,
Hmm.
but the architecture needs to be really well planned before. And you have, for example, uh, new technologies that are coming, like edge computing. So the
Hmm.
computing will be not central at the plant; it will happen close where the so you can solve the leg requests. You will have more smart equipment in the plant. So also you manage all these in the plant and sometimes not in a central computer as we imagine or as we imagined before. So
Hmm.
the new, it will be a decentralized
Okay.
operation. And but you need to control versions. You have to need to control access from what is happening on the field in every equipment. Uh, there is also a certification for cybersecurity, so that's also important. And that's something that you should look if you want a provider for any AI solution, for example.
Sandro, I would like to thank you very much for taking time out of your agenda to talk to us today. It's definitely something that a lot of us are not very familiar with, but I guess within our lifetime we will definitely experience a fully automated, uh, let's say, system with the support of AI driven prediction models. Thank you very much again. I'll definitely stay in touch and see how Turing is doing. Good luck with everything, and hopefully we'll see you soon on the channel again.
Thank you for the opportunity. It's always interesting to talk about this. And well, and again, innovations are coming every day. So uh, probably tomorrow we will have something, not we, but we as humans, we will create something different
Hmm.
and something, and we have to learn how to do it. Okay. But just ignore this. That's for sure. It's not possible in the water industry. We need to handle this.
Have a nice day. Take care, and thank you very much again for the interview.